Determine the points, if any, at which the function has a horizontal tangent line at the function given y equals square root of 3x plus 2 cosine of x, where the x is greater than or equal to 0 and less than 2 pi. So go ahead and find the first derivative. When you find the first derivative of your function, you can go ahead and find the slope and then set the slope equals 0, because when the slope is equal to 0, you're given your horizontal tangent line. So go ahead and find the derivative in respect to x of radical 3x and the derivative in respect to x of 2 cosine x. So y prime equals, I'm going to factor out my constants and put them right within the derivatives of the variables. So y prime equals square root of 3 times x to the first power. The derivative of x to the first power, and that's using the power rule. The power rule states that if you have anything to exponent, it will be the exponent, right? Times x to the exponent minus 1 plus 2 times the derivative of cosine x, and that's just the derivative of the shrink function cosine x, and that's equal to negative sine x. So the derivative in respect to x of y, or y prime, is radical 3 times 1, which is radical 3, x to the 1 minus 1 is 0, plus 2 times negative sine x is negative 2 sine x. So y prime equals radical 3 times 1 plus negative 2 sine x. And so y prime equals radical 3 minus 2 sine x. Go ahead and set y prime, the first derivative, equals to 0. And you can see how your slope is equal to 0. So it'll be y prime, which is radical 3 minus 2 sine of x, equals to 0. Subtract radical 3 on both sides of the equation. It's by using the additive inverse of radical 3, which is the positive radical 3, so additive inverse is negative, so that's why you think radical 3. That cancels out, right? And you're going to be left with negative 2 sine x equals negative radical 3. On both sides, what you're going to do is undo the multiplication of negative 2 by dividing by negative 2. You're going to be left with sine of x equals negative radical 3 divided by 2 is going to be positive radical 3 divided by 2. And just go ahead and ask yourself, from the limits of 0 and 2 pi, those are your upper and lower limits, you have to have a function of sine where number of degrees is equal to radical 3 over 2. Just go ahead and draw your 30, 60, 90 triangle, and the one opposite 30 is 1. The one opposite 60 is radical 3. The one opposite the hypotenuse is 2. So radical 3 over 2 is going to be 60. So x equals 60 degrees, right? Or it equals pi 3 radian. So go ahead and plug in plug into your equation to get more. To get y, because you need to find the point, not just x value. So y equals radical 3 times x plus 2 cosine x. So I'm just going to go ahead and use pi over 3. So radical 3 times pi over 3 plus 2 cosine of pi over 3. Oh, I made a mistake. It's really, I forgot. It's 2 pi. Go back and change it. It's going to be 2 pi over 3 radians. So then this should be 2 pi over 3 radians. This should be 2 pi over 3 radians. So just go ahead and make sure that you make that change right here. That is 2 pi over 3 radians. Okay. So y equals radical 3 times 2 pi over 3. Going to be 2 radical 3 over 3 pi plus 2 cosine of 2 pi over 3. And that's cosine of 60 is going to be radical 3 over 2 times 2 plus y equals 2/3 radical 3 pi. That equals 2/3 radical 3 pi times radical 3. So 2/3 radical 3 pi plus radical 3 is going to be your y. So at point 2 pi over 3, comma 2/3 radical 3 radical 3 pi plus radical 3, there exists a horizontal tangent. In the function